Let us start this new chapter on motion. So the first question which comes is, what is motion? Motion is present all around us. The car that we travel in, it moves. The air right now around us, it is moving. The blood in our veins, it is running, which is a motion. The earth is rotating, which is a motion. The universe is all the time expanding, which is a motion. So motion is a very, very important phenomena which is a part of our day-to-day lives. So we'll start this chapter with our lesson 1. The lesson 1 is on distance time graph. This first lesson is divided in 2 parts. In part 1, this video is about part 1, in which we'll be talking about the distance time graph when the speed is constant. The next video will be on the distance time graph when the speed is not constant but it is changing. So let us start with a lesson 1. Distance time graph. Alright, so let us start with understanding what is a distance time graph. Distance time graph would automatically, if you go by the name, should tell you about distance, it should tell you about time, right? So what do you see on the screen? You right now see on the screen a table. So whenever you have to plot a distance time graph, you need to start with a table, right? You need to start with a table which gives you some set of the values of distances for the corresponding values of the time. Then you start plotting the distance time graph. So how does a distance time graph looks like? If you plot a distance time graph for the table which is given on the screen, it would look something like this. Our distance time graph always has the distance on the y-axis and the time on the x-axis. So our graph which has distance on the y-axis and time on the x-axis is called your distance time graph. So why do we need to plot our distance time graph? Let us look at the 2 sets of data which you see on the screen. The first set of data that you see is in the form of a table. The second set of data that you see is in the form of a graph. Now look at the 2 sets of data. They are the same set of data, but which one do you think is easier to understand? If you look at the table, if you want to understand the table, you'll have to go through each of the readings and use your brain to understand what exactly is the pattern here. But when you plot a graph of it, it is easier for you to understand because your eyes can see the picture of it. It can quickly catch the patterns. Therefore, plotting a distance time graph from the distance time table gives you more relevant and more easy to understand information. So from the distance time graph that you see here on the screen, how would the graph look like if the car would have traveled faster or if the car would have traveled slower? Alright, so let us try to understand. Let's take this thing, all of this thing on a whiteboard. So let us answer this question. How would the graph look like if the car would have traveled faster, if the car would have traveled slower? So you have 2 questions here. Faster and slower. Let us understand these 2 terms. Faster means you are covering the same distance in a lesser amount of time. So right now, if you look at the graph, how much is the total distance traveled by the car? The total distance traveled by the car is 6,000 meters. The last point here gives you that the total distance is 6,000 meters and the total time for traveling this distance is 240 seconds. So if you're talking about faster, you're actually traveling the same distance, 6,000 meters, but in a lesser amount of time. Lesser, let us take a number for example. Say that you're traveling the same distance in 160 seconds. Faster. Same distance, but now in lesser amount of time. So how would the graph look like? The graph would reach somewhere till this point. Let us plot the graph now. It would look something like this. Answering the second question, if the car would have traveled slower. What is the meaning of slower? Slower means you're traveling the same distance but in a larger amount of time. You are moving slow, taking a lot of time to travel the same distance. So this time you're taking a greater amount of time. Let us extend this x-axis. Say this is the time, some time t which is obviously greater than 240 seconds, and you're traveling the same distance which is 6,000 meters and this time which is now greater than 240. Let us assume that this time is say 340 seconds. So how would the new graph look like? Let us plot this graph. It looks something like this. So visually, what do you see here happening? So that's the importance and the beauty of plotting the graph. It gives you some information readily which your brain can catch quite quickly and it is faster to interpret, right? So if the car is traveling faster, look at the gradient of the line. How has the gradient of the line changed? Earlier the line was something like this. Faster, the gradient has increased, right? The graph has become steeper. Slower, the gradient has gone down. So as the speed is increasing, the gradient or the slope of the line is increasing. As you are moving slow, the gradient is decreasing. The steepness is going down when you are slow. The steepness is going up when you are fast, right? So let us come back here. So what did you understand? If the car would have traveled faster, the graph looks steeper. If the car would have traveled slower, the graph looks less steep. Alright, so some notes for you all to make. The steeper a distance time graph is, the greater the speed it represents. So let us understand some basics about gradient. Now this is something which you all would have done in your maths. So let's quickly review it here. So what is gradient? Gradient is the change in the magnitude of y over the change in the magnitude of x. So if you are given a line, how do you find its gradient? You take any 2 points on the line. You find the change in the magnitude of the y coordinate and divide it by the change in the x coordinate. Change in the y divided by the change in the x. Right? But if it is a distance time graph, this is just a normal graph. Let us now convert it into a special distance time graph. So if it is a distance time graph, what will you have on the y-axis? On the y-axis you'll have distance. And what will you have on the x-axis? On the x-axis you'll have time. Right? So when you are finding the gradient for a distance time graph, what do you get? Change in y becomes change in distance, and the change in x becomes the change in x, which is your time. It becomes time. And what is distance over time? Distance over time is speed. So speed. So some notes for you all to note down. Speed in a distance time graph is same as the gradient of the distance time graph. So very easy, whenever you are given a distance time graph and you have to find the speed, you have to find the gradient. Alright. So let us understand with the help of an example here. You are given a distance time graph. Can you work out the speed here? It is simple to do. All you have to do, you have to find the gradient of this line. So let us work out the gradient here. Gradient is change in y over change in x. So how much is the change in y happening here? Right? Which is this minus this, 6,000 minus 0, 6,000 over, how much is the change in the x? This is the change in the x, which is 240 minus 0. This will give you your answer. You can tell your answer, it should come out to be 25 meters per second. Right? Now, let us apply one of the other formulas of the gradient which students are familiar with, right? So one formula which is not in terms of delta, because many students get confused with the term delta. Delta means change. The same thing, delta y means y2 minus y1 over x2 minus x1. Right? This is the formula of the gradient that we all have learned in maths. Let us apply this formula here on this straight line graph. So whenever you have a straight line and you have to find its gradient, this is the formula that is taught in your maths to find the gradient. Let us mark its two endpoints. Let us mark the two endpoints of this line. So what are the coordinates of this line? 240 and 6,000. Let us call it x2 and y2. This is your 0 and 0. You can take any 2 points on the line. You can take any 2 points. You should get the same gradient. But for the simplicity case, we are taking the 2 endpoints, or otherwise you can take any 2 points. You can take any 2 points. You can take any 2 points on the line. Any 2 points, it's your wish, and you should always get the same value of the gradient. So when you apply this mathematical formula, what is y2? It is 6,000. What is y1? It is 0. x2, 240 minus x1, which is 0. Again, the same answer. This whole thing converts to so it should come out to be 25 meters per second. So let us move on with this topic. So now that you know that the speed is same as the gradient of the distance time graph, so let us find the speed when the graph is a flat line, first thing. Then we'll also find when the graph is an inclined straight line, and then we'll also find the speed when the graph is a curve. So there are 3 kinds of graphs possible. Let us understand what this slide is telling us. Let's now come to our white screen. So the speed when the graph is a flat line, right? Flat line. What do we mean by flat line? A flat line is a graph which is a flat line is like this. This is your flat line. Perfectly horizontal. And please do remember, this is your distance time graph. This is your distance, time, right? A horizontal flat line. We know from our understanding of maths that the gradient of a flat line is 0. And what is gradient? Gradient is the speed. The gradient is the speed. A flat line always depicts a 0 speed. Why 0 speed? Because your gradient is 0. So let us understand it. Let us understand what is happening here. Let us mark some values of the time on the axis here. Right? Say this is your time. 1, 2, 3, 4 minutes or seconds, your wish, right? Say, let's say this is minutes, right? And distance 1, 2, 3, 4. Say in meters. So what is happening here? Let us take any 2 points on the graph. Let us compare the value, what is happening from time A to time B. So what is happening between time A to time B? What is the value of the time? Between point A and B, the time value has increased. If you see, the time value has gone up. The clock is ticking, the time is passing by. But what is happening to the distance? You are stuck at a distance of 4. Say that you are 4 kilometers away from your home. You're 4 kilometers away from your home. You are static there. The time is passing by minute, hour by hour, but you're stuck at the same location. When you're stuck at the same location, what does it mean? You're not moving. Automatically it means your speed is 0. And this is what is depicted by a graph, which is a flat line on a distance time graph. So flat line always represents a speed which is 0. Let me write it down here. It depicts a speed which is 0. So first thing understood. Let us now come to the second thing, which is an inclined straight line. Let us now again plot 2 axes. Distance on the y, time on the x. And let us plot an inclined line. Something like this. An inclined straight line. Please do understand, it is an inclined straight. It is a straight line. It is a straight line, but how is it different from this flat line? It is inclined at an angle. It is not perfectly horizontal, but it is inclined. It can be inclined at any of the angles. It can also be inclined other way around, right? But it has to be a straight line. So all these lines that you see here in the picture, line 1, line 2, line 3, they are straight lines. And from a maths understanding of maths, we know a straight line has a constant gradient. A straight line has a constant gradient at all the points. No matter which point you take on a straight line, the gradient is the same. Say that the gradient value here is 2 at this point. The gradient value at this point will also be 2. The gradient value at this point will also be 2. The magnitude of the gradient on a straight line is fixed all the way at any point on the straight line. So an inclined straight line represents a speed which is constant. The speed is not changing. You have achieved a speed and you're maintaining that speed. Say that you're moving at 2 meters per second. So you're moving at 2 meters per second at time 1, time 2, time 3. The time is moving on, but your speed is constant. You're maintaining your speed. This is what is meant by constant speed. So let us write down what we have understood. So for an inclined straight line, what does it prove? What do you infer? That the speed is constant. Constant means if your speed was 2 meters per second, it is 2 meters per second all the time. Or if your speed was 100 kilometers per hour, it is 100 kilometers per hour all the time. Right? Now let us talk about the last point, which is a curve. What if your distance time graph is a curve? Let us draw the two axes. You have distance on the y, time on the x-axis. How would a curve graph look like? It can be like this. It can be like this, like this. All these are curves, right? Let us understand, but with just one curve. Let us remove all the extra curves and let us understand with one curve. Now, curve is a special phenomena where the gradient is not constant, right? You have to first pick up a point. You have to first pick up a point on the curve. If you want to find the gradient at this point, you need to draw a tangent at this point. You need to draw a tangent. Now, tangent is a line which touches a curve at one single point. You have to draw the tangent. The gradient of this tangent, let us call that the gradient is m1. The gradient of this tangent is same as the gradient of this curve at this particular point, which we have marked with a cross mark. Let us take another point. Let us take another point on the curve. If you have to find the gradient at this point, you have to again draw a tangent. Tangent at this point, you'll have to draw a tangent like this. Now the gradient of the tangent is a straight line. Finding the gradient of a straight line is simple. You find the gradient of this tangent. Let's call it m2. The gradient of this tangent is same as the gradient of the curve at this point. Right? Now look at this curve again. What do you see? Its gradient is changing. Right? Its gradient, let's draw a few more tangents in between. The gradient is changing because the tangent's inclination is changing. The first tangent was like this, this, this. The tangent is changing its inclination, therefore the gradient is changing on this curve at different points. The gradient is changing and the gradient is the speed. So therefore a curve tells you changing speed. Whenever there is a curve, what do you infer from the curve? You infer that it is depicting you changing speed. Alright, you all can make notes here, very, very important. If you have not understood these points, go through, rewind and go through this section of the video again. Let us come back to our lesson. So let's find the speed when the graph is flat. So what happens when the graph is flat? We have understood it represents that the speed is 0 because the gradient is 0. Gradient 0, speed 0. If it is an inclined straight line, what happens? The speed is constant. Why? Because it is a straight line. The gradient will be constant at all the points. Curve means the gradient of the graph changes at different points on the curve. Therefore, the speed also changes. A curve on a distance time graph represents a changing speed. If your speed was say 5 meters per second At this moment, your speed after some time is 10 meters per second, after some times 15, then 18, 19, 20. It is not a constant speed, it is a changing speed. Changing speed is represented by a curve. So here we have a few worked examples. You can pause for a moment. Please draw these graphs yourself to understand how the distance time graph looks like when the speed is constant. Both the graphs will give you graphs of a constant speed. Let's look at the answers. Straight line graph represents a constant speed. How do you find the speed here? You find the gradient of this line. When you find the gradient of this line, let us take the two endpoints. 50 over 5, change in y. Change in y over the change in x. 50 over 5 gives you 10 meters per second. Now the second graph again, it's a constant speed, but a higher constant speed. What do you see is happening to the gradient? The steepness of the line, gradient which is same as the steepness of the line, it is going up. Here if you see, the line is more steep. The line here is more steep. Because it represents a higher constant speed. Steady means constant. Higher constant speed, more steep. Here if you see, the graph is less steep. Right? Work these examples now, pause the screen and come back once you are done with plotting the graphs. Then we'll understand the graphs. Alright, so the first graph is the car is accelerating. How the graph looks like? It is a curve. Accelerating means the speed is increasing. Accelerate, and if you understand the term, speed is increasing. If your speed at this moment is say 10 meters per second, after some times it is 15, 20, 25, increasing, you're accelerating your speed. What do you get here? Acceleration means not a steady speed. Automatically you see that your distance time graph is a curve, right? It is a curve. We'll be talking in more details about changing speed in the next video, right? We'll be talking in more details about it. The car is stopped. If you look at the table itself, the time value is moving on. The time value is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, but the distance is stuck at 50. You're not moving at all. If you're 50 meters away from your home, you're just 50 meters away from your home because you're static there, you're stationary there, you're not moving. So what kind of a curve do you get? You get a flat curve, right? So in the next chapter, we'll be talking about the distance time graph for the changing speed. The speed can change in two ways. The speed can increase, which is called acceleration. Example that you have started a car, right, and you have started moving. So you start from zero speed, your speed increases, right, slowly and steadily. That's called acceleration. Speed can decrease. Say that you are reaching your destination, you have applied a brake, your speed goes down. You were earlier moving at a higher speed, slowly and steadily your speed moves down and ultimately you stop, which is zero. You move from higher speed to a lower speed, which is called deceleration. Increasing speed, decreasing speed, how the distance time graph looks like for both the scenarios that we'll cover in the next chapter. Thank you.